So today we're going to be looking at equations of circles. And our equation of a circle is based off of our distance formula. We used distance formula in our geometry course last year. And so we have the distance formula given below, in case we forgot it. And it's the distance between 2 points. And we have this big, long formula with a square root over the entire thing. Okay, we're going to use that formula to come up with an equation for a circle. So circle is a collection of all points that are a set distance, which is your radius, away from a point, which is its center. That's our basic definition of a circle. The circle shown below has a radius of 5. So if I were to look at the circle, I could label this and say that length there from the center to a point on the circle is a length of 5. It has a center point of 4, 2. We have some arbitrary point on the circle, and it's labeled as xy. And I know that we could find a coordinate location for that. That's no problem. But in general, if we were to look at a circle, we could find any point on that circle, whether it's the one located there or a different one over here where maybe I don't even know what size that is, okay, or what the coordinates are. I can call any of the points on the circle this coordinate xy. So we're going to use the distance formula from up above. We're going to show that that point 7, -2 has to lie on the circle. The first thing we're going to do is verify that graphically. So if you were to count over 7, 1, 2, 3, 4, 5, 6, 7, and down 2, I can definitely show you that that point is on the circle. And so if it's on the circle, we should be able to use the distance formula up above to show that this would work. Okay, so if we were to think about this, the distance formula says the distance is equal to the square root of. So now we have x2 minus x1 and y2 minus y1. Just for consistency, I'm going to label this x2, y2, and then I'm going to label this one x1, y1. So if we plug it in, I'm going to have x2 minus x1. We're going to close that and square it. To that, we're going to add y2, watch your signs, minus y1, and close your parentheses and square that. Okay? We want to, orders of operations, simplify inside the parentheses first. So that's going to get us 3 squared. Over here, if we simplify, that gets us a -4 squared. Okay? If we keep simplifying this, okay, 3 squared, we get 9. -4 squared, we get a positive 16. Remember, any negative number squared is always positive. If we add that up, we get the square root of 25, and the square root of 25 is 5. So now think about what we just found. We found the distance from the center point to this point over here has a distance of 5. So I know that that must be correct because they told us up above the radius was a distance of 5. Okay. So using that same idea, we're going to let this point, which we had back here was our 7, -2, we're going to let our x2, y2 be just this plain old coordinate xy, okay? And x1, y1 of the formula is going to be our center point 4, 2. So we're going to write the formula kind of like what we did up above. Same thing, we're going to start with the distance formula. And now keep in mind, the distance between this random point, which we have over here, some random point, and our center point we know is 5. So rather than saying d equals, we're going to say 5 equals, because I already know the distance between these 2 points. Okay, we have our square root. So now again, in our formula, we want x2 minus x1, close it, square it, plus y2 minus y1, close it, and square it. Okay? So that's our distance formula for all points on the circle. So that means any point I take, any coordinate I take, I should be able to plug into here, simplify it, and it should equal 5, so long as it's sitting on the circle. Okay, now to come up with our circle equation, what we're going to do is take our answer from up here, and we're going to square both sides. Okay, so if I take 5 and I square it, and then it's also saying take this whole thing that we have here. Okay, so our whole thing that we just wrote with our x2, x1, y2, y1, and we're going to square it. So it looks ugly, but if I square a square root, I know that those two are inverse operations and they cancel out, so I'm just left with everything underneath the square root. And if I take 5 and I square it, I get 25. And so now what we've actually come up with, this right here, that's your formula for your circle. Okay, so we're actually going to verify this. We're going to prove that this is actually a formula for your circle because the point 1, -2 should satisfy that equation. And if we take a look at the point on the graph, if I go over 1 and I go down 2, again, I can see that that point's on the graph. And since it's on there, I should then also be able to plug it into this and prove that that is a correct formula. Okay, so I have 25 is equal to, place of x, I put 1 minus 4, square that. And then in place of y, again, I have -2, watch your signs, -2, we square it. Okay, and again, to prove this, it's kind of like a test here. I'm saying, is 25 really equal to all of this simplified? Okay, so 1 minus 4, I get a -3 squared. -2 minus 2, I get a -4 squared. Again, we're testing. So -3 squared, I get a +9. -4 squared, I get 16. And when we add this up, I have 25 equaling 25. So what we've just done is we've verified algebraically that that point lies on the circle. So what we've just discovered is our equation of a circle. So we don't always have to go through that distance formula process all the time. It's nice, it's there. We can do that, or we have this formula memorized. That's also going to be helpful. Okay, so it says, what is the equation of a circle whose center is -3, 6 and has a radius of 3? So if we go back to our formula, keep in mind 3, this -3, 6, that's really like the h and the k of your formula, and has a radius of 3, well, that's your r of the formula. So we're going to use our equation that we have, where it says x minus h, so minus a negative, that's plus a positive, squared. And then we have plus y minus k, k is just 6 squared, and that is equal to the radius squared. Now really the only other thing that you would need to do in order to simplify this equation is just simplify the 3 squared. So you don't have to expand this side. In fact, I would probably say don't. Most of your answers are not expanded. The only thing that you're going to have is your radius simplified. That's the equation of the circle, and you're done. Now, a nice little thing that we have on our calculator is we actually have a template that we could use. So if I wanted to add a graph, and then I go back to my menu button, and if I wanted to go to our graph entry edit number 3, and there's something called equation templates number 3. And since we were working with the circle, we're going again to number 3, and take a look at what they've given you. They actually give you that equation. So that's kind of a nice little cheater method. If you ever forget the formula, it's right there on your calculator. That's telling you what the formula is, and then you just have to remember h and k is your center point, and r is your radius. Okay, so what if we already have the equation, and we need to figure out the center and the radius? All right, well, let me just go backwards. So we think to ourselves, remember the formula, if I wrote this up above, x minus h squared plus y minus k squared is equal to r squared. So I know the center point is going to be that hk. And I know the radius is just equal to r. Okay, so if we look at the equation, what they've given us here, our h and our k is going to be 2, 7. I always think to myself, it looks different than in the formula. The formula looks like a -2, but the center is actually a +2. Same thing here, -7, it's actually a +7. And it's again, because that formula has a minus sign in the formula, it's almost like it's going to look opposite. And your radius, I just want plain old r. So right now in your formula, you have r squared is equal to 100. We just want r, so we need to square root both sides. And yes, you do get 2 answers, but again, if it's a radius, it's a length, so I only want the positive length. So the square root of 100 would give me 10. So now we have your radius. Okay, we'll try another one. So we're looking for your center. So I'm going to take these values, and again, it might be easier to think to yourself, you want to think flip the signs. So this looks like a -5, it's really going to be a positive. This looks like a +8, it's really going to be a negative. And then to get your radius, right now in the formula you have r squared equals 4. So when you square root it, we take the positive value and r would equal 2. So we have your center and your radius. Okay. For letter C, it looks a little different. We have x squared plus y squared. Well, this is the same thing as saying x minus 0 squared and y minus 0 squared. It's just we typically don't rate the zeros. And so when no number is showing up, we can think to ourselves the center is going to be the coordinate 0, 0. And again, our radius, they've given us r squared. So if I square root that, our radius is 11. Okay. And I'm going to leave these next 3 for you to try. So you can try these on your own. If you have questions, let me know. I'll give you the answers so that you can check your work in class. If you have questions, bring them to class and we can go through them. Okay. So our next question we have here is we're going to write equations for circles A and B shown below. Okay, so if we're going to write the equation of our circle, I'm just going to write our formula up above. X minus h squared plus y minus k squared equals r squared. So we need to know the center and the radius. So we know the center on both equations or both circles. What we don't know is the radius. Okay, so we have options on how we could do the radius. You could do the distance formula. I'll show you that distance formula on this one here. So I'm working on circle A. And if we were going to do the distance formula, remember the distance is the square root of, so we're going to have x2 minus x1 squared plus y2 minus y1 squared. Okay, and if we simplify, 6 minus 4, we get 2. 4 minus 1, we get 3. So 2 squared is 4. 3 squared is 9. And if I were to add 4 plus 9, I'm going to get 13. So I have now my radius. That's going to be the square root of 13. Okay, and now we're going to write the equations. We have our centers. We have x minus 4 squared plus y minus 1 squared equals, now we need the radius squared. So I'm going to take the square root of 13 and square it, and that leaves us with 13. Okay. Another way that you could do this to find the radius length is realizing we could create a right triangle. And the distance formula is always based off of the Pythagorean theorem. So if I can find the distance between these two x coordinates, so between -2 and 1, I have a distance of 3. And then find the distance between the two y coordinates, and the distance there is 4. I could think for circle B, all I'd have to do then is the Pythagorean theorem. So your Pythagorean theorem would say 3 squared plus 4 squared would equal the radius squared. A squared plus b squared equals c squared. So if we simplify, you have 9 plus 16 equals the radius squared, or 25 is equal to the radius squared. So if we simplify that, it's telling you that the radius then is 5. Okay, now you can write your equation using your center. So we would have x minus a -2 squared plus y minus 4 squared is equal to your radius squared. So 5 squared is 25. So that's 2 different methods on how you could find your radius, either the distance formula or the Pythagorean theorem. And now lastly, we're going to take a look at how we can use completing the square to get our equation of a circle back into center radius form. If you remember back on the calculator, we had 2 forms. The standard form, that's what we're basically in right now, versus your center form. Center form is what we've been working with. So if you remember completing the square, we only had 1 term that we had to complete the square on. In this case now we have 2, both the x's and the y's, but it works the same way. Step number 1 was always get the constant by itself, which it already is. I'm going to rewrite this. I'm going to give myself a little bit of room, and just like we did before when we completed the square, I'm going to add in a box of information. And I'm going to think to myself, I'm only doing the x's. I'm going to gather those x's. Then I'm going to rewrite my y's. And again, I'm going to add in a box of information. Okay, and again, the y's are going to remain together. And then keep in mind, over here, I have the 2 boxes that I have to fill in, one from the x and one from the y to balance it out. It's the same process that we did before with completing the square. So I find my middle term. My middle term is 10. Take half of my middle term, which is 5. Take 5 and square that. It's me 25. And I'm going to add that to both sides. Okay, we're going to do the same with y. Find my middle term. Watch your sign on this. My middle term is -2. I take half of -2, which becomes -1. We square -1, and then it becomes +1. And then we add that to both sides. Okay, and now we make our factors. So like we said before with our factors, whatever half of your middle term was, which in this first factors, half of the middle term was 5, that becomes the factor squared. Okay, do the same for the y. So half of your middle term, half of -2 is -1, that's your factor squared. And then over here, we just have to combine. So I have 10 plus 25, that's 35, plus 1 is 36. So now we have found the equation of our circle, and we have to determine the center and the radius. Okay, so the center, in this case, -5, +1, and the radius is, remember, I have 36 is equal to r squared. I just want the radius, so I have to square root it. My radius is going to be 6. Okay. Bring any questions that you have to class. Again, if you try those up above and you need a little bit of help, the questions that we had skipped on the top part, or I'm sorry, on this page over here, please let me know, and I can help you with those answers. We can check your work. Okay, hope you guys have a great day.